ile Chatelier's principle le Chatelier isibongo somuntu ungazocabanga ukuthi igama le science, it's just a surname komuntu njengoba nawe nje mhlawumbe wakamthembu ivuna kubeziwa nomthembu's principle, mina njengoba ngwakamaseko nje umaseko's principle. That is why sithi le Chatelier's principle. Le Chatelier mengi summarize yonke principle yakhe uthi ke yonke system ekhona under the sun ifuna ukuthi ihlale equilibrium. Yonke system ekhona under the sun ifuna ukuthi ihlale equilibrium. Ngamanye amazwi i-system once it reaches equilibrium then that is good for the system. So each time when you disturb the equilibrium wenza ukuthi ingabisaba in equilibrium, i-system yona ke iyokwenza indlela yokuthi ekugcineni ibe buyele kwi-equilibrium. Yeah. Kusho ukuthi ngamanye amazwi the system will always try to maintain equilibrium. So each time when you try to change conditions equilibrium, or we can say it's conditions surrounding equilibrium, once you try to change those conditions, then the equilibrium itself will do something, will try to work against what you have changed. Iyaphikisa equilibrium. So the equilibrium, the Chatelier's principle, ikhuluma kanjalo nge-equilibrium. It when an equilibrium or when a system in equilibrium is subject to change, an equilibrium will shift in such a way so as to work against, to counteract, so as to counteract the change that is imposed. You impose a change, equilibrium will try to work against it. In our bodies, we are having different systems that are in equilibrium. Let me give you an example. Maybe umzimba wethu ake ngithi ngabomu yonke into esemzimbeni yethu sithola ukuthi amanzi they constitute, let's say 60% or 70%, let's say 60%, just for argument's sake, let's say 60%. So wonke ama-systems ala emzimbeni controller ukuthi amanzi nawo awu 60%. So ama-system ala emzimbeni aku-equilibrium. Bese ke uyasuka ke wena uzodisturba ke le system esemzimbeni uphuza amanzi amaningi. Mawuphuza amanzi amaningi, i-system yofuna ke indlela yokuphungula lawo manzi. Wena waphuzile, system yofuna indlela yokuwaphungula. Bese ke uya kuleyo ndawo bese umuntu athi ngicela ukuyochitha amanzi ngoba phela uyophungula phela lawo manzi. I-system will work against you. It will try to remove what you have added, or what you have removed, the system will try to add. So keep amanzi, mawukhipha amanzi kakhulu, i-system yenza ukuthi wome. So womile manje. Uyobona noma ujima, uyajima ujuluke. Uyajuluka. You sweat. You lose water. As you lose water, system it okay, ungijulukisile lo, ungiluzisa amanzi. Bese it makes sure ukuthi uyomela amanzi. Uzothi mawuqedile ukujima, uyofuna u2 liter wamanzi or we-coke, uthi ka. Uphuza uthi hey, kwathi icosololo. Akuyona icosololo. The system is trying to work against you. Now we have 3 factors. In fact, there are 4. The fourth one, banokuyifaka kwezinye incwadi azibayifaki. But we have got 3 major factors that disturb equilibrium. The first one is the concentration. Concentration. That is the first one. The first factor, concentration, it disturbs equilibrium. The second one is temperature. Temperature is another factor that can disturb equilibrium. The third one is pressure. Pressure can disturb equilibrium. Concentration, temperature, pressure. The fourth one, it's not mentioned because by mention as part of concentration. By it's a common ion effect. Common ion effect. Common ion effect. So that is another factor that can disturb equilibrium. Now, let's work on concentration. Concentration. What is concentration now? It's the number of moles in a given volume. So, a number of moles in a given volume. But now let's say reaction in volume whatever changes that you do, the volume remains constant. So, volume subject of the formula. We make volume subject of the formula. Now we see the relationship between concentration and number of moles. As you increase the concentration, you are increasing the number of moles. Now let's say you are having this system is in equilibrium. The system, the following reaction takes place in the same volume. Let's say a volume of 2 decimeter cubed. Now this reaction occurs in a volume of 2 decimeter cubed. The volume is the same. This reaction has reached equilibrium. Now what if you disturb equilibrium by changing the concentration? The concentration as the first factor. How does concentration affect equilibrium? Changing concentration. Let's say you increase the concentration ga A no P. You add more of A and P. As you add more, you add the number of moles, you increase the concentration ga A no P. Njengoba increase the concentration ga A no P, i-system iyabona ukuthi so ufake manje u-A no P omningi, yona-ke it will work against you. Bathi ngesingisi esihlangene nese-science, but it will counteract. It won't act, it will counteract. As mebethi yobona noma kudlalwa ibhola, abantu mebeni attack, nina niyathula nje, nilindele ukuthi bani attack. Uma sebeni attack, then bese nina niyaphindisela. Bese you are doing a counter attack. But le team le ama counter attacks. We attack I bese mase iphindisela nawe awuthandi. Nalana ku system ufaku A and B, then the system will counteract. What will it do? Iyazama ukuthi iye inciphise lo A and B lo AD. Izama kanjani? When you add A and B, it's in collision theory. You are increasing the number of moles of A and B. By increasing the number of moles of A and B, you are increasing the chances of collision between A and B. more increased chances of collision between A and P, then this affects the rate of forward. I'm explaining what the affect kanjani. U-add ama-reactants, the rate of forward will increase. Bese ngi-summarize lapho. Kodwa mengichaza phela. U-add ama-reactants, you are increasing the number of modes of A and B, you are increasing the chances of collision of A and B, then the rate of forward reaction is favored. Summarize. When you increase the concentration of reactants, then the chances of collision will increase, then the rate of forward will increase. Now, uma inyuka rate of forward, kwenzekani na? Lo kuyamanje okade sokuedile kuya ngokuncipha. Yancipha. Ekuncipheni kwayo kwenzekani kwakheka u-C and D. Ngamanye amazwi uma u-add u-A and B, i-system iyofuna ukwakha u-C and D. Ngokwakha u-C and D, kusho ukuthi manje i-concentration ka-C and D izonyuka ngapha manje sekuzwenza njani na? Kuzoncipha. It is stable phela manje system. It all right, no problem. What I'll do, when you add A and B, when you add the concentration of A and B, when you increase the concentration of A and B, then you're increasing the chances of collision between A and B. Then the system will make sure that the forward reaction increases. The rate of forward is increased. As the rate of forward increases, then more of C and D will be formed. As more of C and D is formed, and lena iyancipha, i-forward izoncipha ngoba kuncipha manje la. I-reverse izokwanda ngoba kuyanda manje la kwa-C and D. Then at the end of it all, a new equilibrium will be re-established. Ungathi will be established. Phela ayikhona ngaphambili, isekhona namanje. Hallelujah. Washo njalo ukuthi hayi wayikhona usekhona. Sikhuluma ngesystem thina lena ye-equilibrium. So ke ngamanye amagama iqala uma u-add u-A and B, kuqala ku-increase i-rate forward. Ngoba phela u-add u-A and B. Ngoku-increase i-rate forward, iyenze njani na? Iyakha u-C and D. Ekwakheni kwayo u-C and D, concentration ka-C and D iyanyuka, ka-A and B iyancipha. Ngokuncipha kwa-A and B kuyancipha i-rate forward manje, liyana kade inyukile. Leyana iyanda, i-reverse. Ize iyolingana, sekulingana-ke lokhu okwama-products. Now, ngenxa yaleso simo kuwakheke ama-products, i-concentration ama-products iyandile, then we say the equilibrium shifts to the right. The equilibrium shifts to shift by way. Equilibrium shifts to the right. Move to shift. Oh, I'm shifting. So equilibrium shifts to the right. He move to the right now. Who right while the equation? So more of this is formed. So njengoba kuwakheka u-C and D, now at equilibrium, a new equilibrium will be re-established. If a new equilibrium is re-established, then we find that the concentration of C and D, iyobe se higher, A and B will be a little bit lower. Iyobe se incipile phela ngoba uke wa-add yancipha yazi kwaba into engaka. Yebo manje sesiyezwa maseko uyibekile ngaleyo ndlela yoku-add. Bebheka-ke asikhulume nje sibheke isiZulu nje, sikhuluma isiZulu manje isiZulu. U-add ngapha ngokuma-reactants. I-system izonciphisa ama-reactants ngokuwandisa ngalena. Meyandisa ngalena, lokho ku-addile kuyancipha. Lokho kunga-edwanga kuyana, bese kwenzekani? Ekwandeni kwapho ngapho kuncipha kuyofika to a point where i-rate forward ilingana ne-rate of reverse. So kwandile-ke ngapha, yikho lokhu sithi i-equilibrium shifts to the right. Right. Siyaqhubeka. What if you decrease? Angasebenzisi i-cycle load. You remove you remove ama-products. Njengoba kade kwi-volume njena, ukhipha kancane ama-products, uyawanciphisa. Okay, mwanciphisa i-system izothi, oh, uyangiphuca manje ama-products. Ngiyofuna indlela-ke mina yokuzakhela ama-products. It counteracts. You add, it subtract. You subtract, it adds. Yeah, system injalo. Uphuza amanzi, uye toilet. Udla usawudo omningi, ngoba modla usawudo omningi, your water potential drops. Bese kwenze njalo. Modla usawudo omningi, kufuneka amanzi manje ukuthi ukwazi ukuthi lo sawudo uncibilike kangcono. Hey. Listen to this one. When you remove CD, my products, ekunciphiseni concentration yama products, ukuzokuncipha i-number of moles yama products. Ayancipha ama number of moles kade ekhona kuma products. Mayincipha i-rate of reverse na izoncipha, ngoba ama-chances of collision between C and T will decrease. Uma i-rate of reverse incipha, unciphisile, izomake sure ukuthi hayi buka ke manje asakhi kakhulu ama-reactants. Ama-reactants kumele abe akhe kakhulu kunathina seyakha ama-reactants. Ngamanye amazwi, when you decrease the concentration of C and D, you are decreasing the number of moles of C and D. You are decreasing the rate of reverse. The concentration of products or products, they control the rate of reverse, while the reactants, they control the rate of forward. So uma unciphisa la i-reverse iyancipha. Uma incipha ekuncipheni kwe-reverse kwenza ukuthi u-forward abe more than u-reverse. Ake ngiyibeke kanje. Umoyiswa yini u-forward? Uyezwa na kusho ukuthi isingisi leso. Isizulu esihlangene nesingisi. Umoyiswa yini i-forward? Why u-forward abe more than i-reverse? Hayi ngoba u-forward eyandile, yingoba i-reverse enciphile. Nansi i-choke. Naba bochoke ababili bayalingana. Ngithi le ilingana nale. Kodwa uma ngingahlephula le eblue, lena manje seyingaphezulu idlula le. Idluliswa yini? Hayi ngoba ikhulile, ingoba le inciphile. Sesithi le inkulu kunale. Hayi imnandi ke le. And I know this concept. Abantu abaningi yabadida, especially abantwana baka-matric, but not a person who is watching this program. You are not confused. You know what I'm talking about. As I'm now leso. Ngamanye amazwi, uma unciphisa i-concentration yama-products, the rate of reverse will decrease. If the rate of reverse is decreased, then forward will be more than the reverse. As forward is more than the reverse due to the reduction of the rate of reverse, then if forward is more than the reverse, then izokwakha kakhulu u-C and D. Unciphisile iyazakhela ngokuthi inciphise u-A and B, uzoncishiswa yini ngoba i-forward manje it's more than the reverse, iyakha kakhulu u-C and D. Ngale nkathi yakha kakhulu u-C and D, i-reverse manje izoya ngokwanda ngapha ngoba kuyaphela i-forward izoncipha until a new equilibrium is re-established. Unciphisa u-C and D, i-equilibrium izoshiftela kuphi na ngaka-right. Hawu, uma sekwasethi nga-right, wayisho njalo. Lalela phela ngiyixoxe le ndaba. Ngale nkathi ngisusa u-C and D, ngisusa u-C and D. Hayi, i-system iyofuna ukuzakhela. Uma zakhela i-system iyazakhela. Njengoba i-system izakhela njena, iyokwenzani? Izonciphisa i-rate reverse. ekunciphiseni rate ye-reverse hayi kwenzekani na i-forward iba more than i-reverse uma i-forward say more than i-reverse iyakha kakhulu u-C and D uyayibona ke miyakha kakhulu u-C and D lo C and D okuphi na uku-right kwe-equation kusho ukuthi the equilibrium will shift to the right miyakha kakhulu C and D kwenzekani u-A and B iyancipha i-rate ye-forward iyancipha kuyakha kakhulu C and D i-reverse ama-products ayanda i-reverse iyanda until a new equilibrium is re-established. Sesibonile-ke the effect of concentration on equilibrium. Right, siyobona-ke mase sibheka ama-questions sesiyixoxela. What about temperature? How does temperature disturb equilibrium? Let us look at Haber process. Hey, the process in the Haber. Nitrogen plus hydrogen is in equilibrium with ammonia. We balance that. Gases, gases, gases. Let's say, for instance, delta H is less than 0. We have a process bakwethu. Sithola ukuthi i-reaction is exothermic. When you form ammonia, energy is given off. Heat is given off. Means energy ne heat nisashunta yodwa. Or ake ngishathise-ke ngoba phela so ibambe lapho mina songumfundisi ngishathisa u-energy ne-heat. Energy in a form of heat is given off. Asayishathile. Ake sa-divorce. When we talk of energy, we're talking of energy in a form of heat. Kulama reactions. Right. What happens? Now, this being an exothermic reaction, again, we understand it. N2 gas plus 3H2 gas produces 2NH3 gas. Heat is given off plus energy. This reaction is exothermic because energy is a product. Njengoba ukuyele ku-produce energy, mawubuyele muva, i-ammonia idinga i-energy to form that, to form nitrogen and hydrogen. So now, njengoba i-forward reaction isakhela i-energy, then we call the forward reaction exothermic. I-reverse yakhona, this requires energy to form this nitrogen and hydrogen. Then the reverse is endo. This requires energy. Energy is taken in the reverse process. Energy is taken in. As energy is taken in, then it forms nitrogen and hydrogen. So this reaction is, the forward is exo, the reverse is endo. Now, if the forward is exo, the reverse is endo, sensitivity temperature, the effect of temperature on equilibrium. The forward is exo, the reverse is endo. Now, we example ngabuza, but what type of reaction is that one? Yeah. Type of reaction. Once but the type of reaction, but so we should forward. Mati delta H, I see two sub-questions here. Consider the following reaction in equilibrium, where delta H is less than 0. Question number 1. What type of reaction is that one? Exothermic. Let's wait, question number 2. What type of reaction is the forward? The forward, it's still exothermic. Ngamanye amazwi uma bekhuluma nge-forward basuka kwi-equation isuka from left to right, sisuka ngapha ukuya ngapha, forward. I-forward ifana noma bengashongo baveseni bathi what type of reaction is that one, bayithulele nje basuka besho forward, kuyakuhlebela ungatsheli umuntu. Yabona uma ufuna ukuthi indaba ihambe ithini, ungatsheli umuntu. Nalo mngani wakho uyofika athi hey yazi mngani wami bathe ngingatsheli umuntu kodwa wena ngeke ngakutsheli. Nakuhlebela-ke mngani wami ungatsheli umuntu. Uma bebuza bathi what type of reaction basuke besho ini na, forward. So if it's exothermic, forward, then this type of reaction is still an exothermic reaction. Now you disturb equilibrium. How does temperature affect equilibrium? When temperature is increased, you increase temperature. Sibuyela sithi reverse, sikhulume ngama rates of reaction. With rate of reaction, whether the reaction is exothermic or the reaction is endothermic. But for it to occur very fast, temperature, you increase the temperature. When you increase the temperature, forward the reverse kuyafana, because we increase. But the temperature increases the kinetic energy of the particles. Whether I'm a product, no mama reactants, kuyonyakaza konke ngoba unyusa i-temperature. Futhumeza amanzi wena. Beke ziko amanzi ezunyakaza konke phakathi, ayikho iphathe ngeke inyakaza, kuyanyakaza konke, nyakaza. The more ushisa amanzi enze njani, aqhume lize lishaye ikhwela iketele lithi hayi bo shaye ikhwela awuzosiza nakho abantu belwa phakathi kwami ngale nkathi uthi ufaka umuntu ngoba uthanda indaba, uthi ufaka umuntu lezi zinto ezilwayo zikhiphela ukulwa kuwena bese ukhipha amasinye izandla kuyangishisa fanele uyaphi ngenaphi wena amanzi eshayisayo. Now when you increase temperature, both rates increases. Now when you increase temperature, ngamanye amazwi you are adding energy in a form of heat. Ake ngibeke njengoba ngibeke nje. More add energy in a form of heat. Ku add energy. The system is kek. Add energy. Hi. Yazi ngizenza njani? Ngizofuna ukunciphisa le energy. What will happen? When temperature is increased, both rates increases. I-exo izonyuka, ne-endo izonyuka. But i-endo iyanyuka i-exo bakwethu, yebo. Anginikeze i-endo omunye umbala. Uze nibone. Iyanyuka i-endo. I-endo manje izonyuka kakhulu kune-exo. Yayibona? Ngoba i-endo ithatha umsebenzi wayo iyathanda ukuthatha energy. So when temperature is increased, the rate of forward will increase and the rate of reverse will also increase. Why does both rates increases? Because their kinetic energy is increased. Temperature is a measure of kinetic energy. When you increase temperature, kinetic energy increases. Zonke is increase. But your reverse will increase more than your forward. As reverse increase more than your forward, kuzokwenzekani na? Leli side liyoncipha manje. Kuyoncipha yini na i-NH3. Kunciphe yini na naleya energy. I-system iyasizakala. You add energy, kulungile ngizoyithatha le energy ngiyokwakha ngapha kwakheka yini na ama-reactants. Now in an exothermic reaction, when temperature is increased, the equilibrium will shift to the left. In an exothermic reaction, when temperature is increased, the equilibrium will shift to the left. which means more reactants will be formed. Ngoba ama products, energy is one of the products. And you're adding energy, the system will try to reduce that energy. So what will happen? As temperature is increased, the rate of forward will increase, the rate of reverse will increase. But endothermic will increase more than the rate of than exo. Then bese shiftela ngapha. May shiftela ngapha bese kwenzekani? Kunciphe ngapha, uwande ngalena ngoba kuwanda ama reactants, kuwanda laphana. Then a new equilibrium will be re-established at a higher temperature. So we have something of this nature. Thina sezwile. Hayi impela uyayisho lento yakho. Sokuyinto yami manje. Akusase into ye-science basho njalo abantu. Uyayisho lento yakho. Hayi bo. Akuyona into yami lena. Yiqiniso nje. Yiqiniso ilokho okwenzekayo. Right. Ake sithi ngabo you decrease temperature. Unciphisa temperature. You remove heat. Njengoba kumakhaza nje. Ingoba temperature yethu iyancipha. Uyifaka endaweni emakhasa. Ufaka leyo container efridge. Yini umsebenzi wefridge bakwethu is to remove heat. Ungathi hayi ngenwa amakhaza, hayi. Nakuthola ngenwa amakhaza bakwethu awangeni kumuntu. It's either you gain heat or you lose heat. Yikho lokhu mubona umuntu ekuseni ngokumakhaza. Ungazicabanga ukuthi uyasha, uyashunqa la ekhanda ekuseni. Yini? He loses heat. Njengoba eshunqa nje, futhi la banempandla njengoba engena inwele nje, kushunqa kakhulu umuntu. Njengoba kushunqa njena, energy is lost in a form of heat. Bese uyaqala manje, uyagodola. Angikho lapho, ngilapho. When temperature is increased, kwenzekani la? You remove energy. When you decrease temperature, energy is removed. The system will try to work against you with Chatelier energy. The system yofuna ukuzakhela energy. Kanjani? When temperature is increased, both rates decrease. Kuyancipha lokhu kokubili. Ngoba phela i-temperature ishaya ngapha nangapha. I-temperature affects the rate of reaction. Yikho lokhu sithola kuma-factors that affect the rate of reaction. I-temperature futhi i-disturb equilibrium. Yikho lokhu sithola kuma-factors that disturb equilibrium. Temperature. Shaya kokubili combo. Unyusa temperature, kunyuke i-rate of reaction. Disturb futhi equilibrium. Yeah. I find the catalyst. A catalyst does not disturb equilibrium. Catalyst nje yona ekwenzayo nje iyenza ukuthi i-system isheshe ifike kwi-equilibrium. Catalyst. Now, when temperature is decreased, both rates decreases. Kuyancipha i-exo. But i-endo decreases more than exo. I-endo iyazwela bakwethu. Ngisho njalo mase ngifundisa eklasini ukuze bangilalela abantu bangi-understand. I-endothermic iyazwela. Unyusa temperature inyuka kakhulu. Unciphisa temperature incipha kakhulu. I-endothermic. You increase the temperature, endothermic increases more. It increases more than exo. You decrease the temperature, it decreases more than exo. So I say, if temperature is decreased, both rates decreases, but exo decreases, endo decreases more than exo. ake sithi nakho kuyalingana equilibrium i-reverse i-forward le e-blue i-endo le emhlophe i-exo uma unciphisa i-temperature both rates iyancipha but i-exo incipha kancane asinciphise kancane i-exo senga but i-endo incipha kakhulu yabona i-endo inciphe kakhulu kune-exo kugcina sekuyini i-exo more than i-forward more than i-endo i-exo imoyiswa yini isingisi leso kusona isingisi esihlangane nesizulu i-exo why iba more than i-endo it's because i-exo has decreased less than endo or endo has decreased more than exo mase inciphe kancane la le inciphe kakhulu what will happen the equilibrium will shift to the right ngoba i-forward will be more than i-reverse uma say more than i-reverse kuyanda la nani futhi naleya energy kade uyikhiphile iyazakhela i-system yenze njalo khipha wena i-temperature iyozakhela yini energy khipha wena i-energy iyozakhela yini energy add energy iyoyinciphisela i-energy so lana bese kwenzekani na in an exothermic reaction when temperature is decreased the equilibrium will shift to the right when temperature is increased the equilibrium will shift to the left lana sikhuluma ngani na ye-exothermic reaction in an exothermic reaction this is how temperature disturbs equilibrium. When you increase temperature, the reverse will be favored. The endo will increase more than exo, hence favoring the reverse. As the reverse is favored, then the concentration of reactants will increase, while of products will decrease. Hence we say the equilibrium will shift to the left. Once the temperature is decreased, in the piece, which is ngiyazi abanye abasayizwa ukuthi ngithi in noma d kodwa bayayizwa ucrease nciphisa temperature you decrease temperature what will happen both rates will decrease the endo will decrease more than exo then exo will be more than endo ngoba inciphe kancane le inciphe kakhulu le then the equilibrium will shift to the right kusho ukuthi izowakha leli side la i-energy ibe kade ikhona le kade inciphiswe khona izozama uku-edda leyo energy then the equilibrium will shift to the right as the equilibrium shifts to the right then the rate of exo izoncipha then endo will increase until a new equilibrium is re-established at a higher temperature. So sesibonile the effect of concentration, the effect of pressure, how the affect kanjani equilibrium.